So, good morning, everyone. Can you hear my voice? Say yes or no to me once. Are you clear with my voice today? Cross check it once. Okay, Andy. So, 2 minutes. I'll repeat the session yesterday for 5-10 minutes. And today I'll do more operations based on stream. That is a plan for day 2. Yesterday, the information is flow of data or flow of objects. You can call it as a stream. Stream always represents continuous flow. Continuous flow of data or continuous flow of objects. Continuous flow of data or continuous flow of objects. Stream API means working with the flow of objects. Working with flow of objects. I given some support points. Whatever I'm speaking, I given some support points. The stream API is used to process collection of objects. A stream is a sequence of objects that supports various methods which can be pipelined to produce desired result. I tried this yesterday to explain that what is pipelined process. In a pipelined process, definitely the performance of an application will be very high and execution time will be decreased. To introduce that stream, we must know basic types of objects. There are 3 basic types of objects where user-defined class objects will hold user-defined data. Wrapper class objects will hold primitive data types. String objects will hold string data. To hold multiple objects or collection of objects, we have to take the support of array or collection or map. That's the information I delivered yesterday. What is the features of stream? A stream is not a data structure. Instead, it takes input from the collections, arrays, or any other IO channels. Stream do not change the original data structure. They only provide the result as per the pipelined methods. What kind of operations you can perform on stream? 2 types of operations we can perform on stream. One is intermediate operations and terminal operations. Two types of operations we can perform: intermediate operations and terminal operations. The operations which are performed in between stream is known as intermediate operations. The major one I highlighted with map, filter, and sorted. The following are some important intermediate operations. Terminal operations. The operations which are performed at the end of stream are known as terminal operations. I highlighted 3 important ones: collect, for each, and reduce. So today, let me work more specifically. and notes will come. Don't worry. I not yet edited and posted. You have to wait. If you take one map, at least whatever you learn it, that may be 2 or 3 methods, you must have a grip on it. So the map method is used to return a stream, consisting of result, consisting of result of applying the given function, applying the given function to the elements, you can say. The map method is used to return a stream consisting of result of applying the given function to the elements. Structure, or you can say method signature, you can say. At least you must see the method signature. Let us open the stream. We are working on stream now. We are opening java.util.stream.stream. Here you can see the map. You can see the map. The method, you can see map. Some methods I brought it. So public abstract, I'm writing it, R, generating some result. R stands for result. The return type is java.util.stream.stream, taking the result. Map of, you must know the parameter also, java.util.function, util.function, function, super, T, and extends from R. Why I'm showing the method signature means it is looking different. Everybody knows T. R stands for result, generic representation result. Sir, what is this function? I want to see this function. API means looking into library. I am learning stream API means program looks very simple, but understanding few components available from the library. You are having one function here. I want the structure of function. I want to see that function. I want to see the function. Whenever you want to see the function, java.util.function can see. Can you see this function? Right. All of you can observe this. Anybody can see it and say how many abstract methods available? How many abstract methods available? Anybody can type in the chat box to me? Very good. Very good. Very good. So you're observing. Who answered one? That is correct. Only one abstract method, apply. Abstract method, apply. If any interface holding single abstract method, you are calling that interface as what? What is the name of that interface? Very good. Sir, it is a functional interface. So function is a functional interface. If anybody asked in your interview questions, so function is a functional interface holding one method known as apply. So functional interface advantage is what now, sir? The interface can hold lambda expression. Yes or no? Functional interfaces can hold lambda expressions. That's the target. So that function can hold lambda. Why I'm introducing this function means I'm introducing one new component to function coming from the sub package known as function, having one abstract method. We call it as a functional interface. Now I am writing that like this. For document purpose. This is one function. I am highlighting the abstract method. I am highlighting. Remaining I am not highlighting. I am highlighting this abstract method or and so on. I am highlighting. This is function. Now, whenever the function is there, this will accept lambda. This will accept the lambda. Will accept the lambda. One example program, I will take it. Now you'll understand. Whenever I'm taking now, because you understood the map definition, map is nothing but providing one result of elements based on applying one function. By applying one function on the elements, map is going to generate one result. That function, how you are applying that function means that map parameter is function. When the map parameter is function, in the place of function, I can write lambda expression. I can write lambda expression. And this map can be accessed by stream object. So stream.map, I am passing this lambda expression as parameter. Now you are connected yourself for the syntax. Say yes or no to me. By seeing these structures, have you got imagination of your syntax? If you can learn that by seeing the syntaxes, if you can imaginate one by seeing the structures, if you can imaginate one syntax, you'll become a code writer. Now see there. I want to run one map method. Whenever I want to run one map method, the map method belongs to stream because I am opening from stream. I must access with the stream object and the map method passed with the function as parameter. The function is one functional interface. So I can pass lambda expression as parameter. So hope you can imagine the syntax. I am writing, observe it. Now I am taking one program here. Some demo program 3. I am concentrating on map. I am concentrating on map. import java.util, import java.util.stream. I'm working with the stream API. What's the meaning? I'm creating list of integers. I'm creating OB equal to. There are two ways of creating list. One, create one object of any implementation. I'll take array list and integer. I will take it. I can add some elements to it. Add of new integer of some 11. I can take it. Like this, I can add some objects. Why cross mark is coming means that is marked for removal from Java 9 version onwards. The syntax is marked for removal from Java 9 version onwards. Anyway, the answer will come. Some 11, 10, 7, 18, some answer. This is one way of creating one list. Sir, I want to create one immutable means list of I can write it. Some elements I can write it. Some 2, 1, 6, 4, some 5, some elements. This also list only. All of you understood of method? All of you understood of method? But here immutable object is created. What object is created now? Immutable object is created. I can do some operations. I cannot modify the operations. I cannot modify the data. No, sir, I want to modify the data means you go with normal add it. Very good, Rahul. So this is a method introduced by Java 8. We can create one immutable object. Now our concept is connected to the stream now. Stream working on integer. I'll make it SM is equal to OB dot stream. I connected to stream. One stream is connected now. When the stream is connected here, so stream is connected. Once the stream is connected, I can perform operations. So whenever I want to perform operations here, I had some terminal operations no here, terminal. In this terminal operations, I can display it. For each method will say that you can display. Collect method will say that you can collect that elements into one list or any other. Collect method can generate one list. So I am using first normally SM dot. I want to use map function here. Some X. I am applying one function X into X dot for each display it. First I am displaying that. Like yesterday, I am displaying. So system dot out dot print ln y. I'm displaying. Already I'm displaying that from there. Here not needed. Run it. the answer will come. So first display normally system.out.println normal list I will display. System.out.println ob.toString. Then I am applying one function and I am using map method. I am using map method. This is map. Normal list is this one. After map, I am getting the answer. What is the answer means? 2 into 2, 1 into 1, 6 into 6, 4 into 4, 5 into 5. I am applying one function on the elements. So map will generate one stream, by applying one function. If you want to apply one function and generate one stream, we take the support of map. Not only concept. Map is used to generate one stream by applying one function. All have understood map method? Say yes or no to me. All have understood map method? You can write one function and generate it. That's called map. Right. That function is x is equal to nothing but x mapping onto x into x. At least one method you must know, map. Okay, right. See there. Now I am using one terminal operation here. The terminal operation is for each. I am using. Whenever I use for each, the answer is coming out. For each, the answer is coming out. Sir, not like this. I want you to do some, collect into one list. I'm using for each method. Why don't you use collect? Collect method is going to collect it. Collect method is going to collect it. So let me use collect. sm dot map carbon only, map of. I am finding x and x into x roughly dot collect. I am using dot collect of collectors dot to list. I am converting into list. I am generating one list here. Collecting into one list. I am collecting into list. Here I am displaying with collect method. Using collect. So terminal method. Terminal collect. Whenever I use collect here, I am collecting into list. If you want to see what is available in the list now, you can display it. At last, you are going to display that only lst dot for each. On the list also, for each will work. Yes or no? For each method will work on the list directly. So for each method will work on the list also. For each method is a terminal operation from stream, but for each method will work on the list also. Anybody can say how it works on list? Sir, how it works on the list means your list is a child of collection. You know that already from the library. Java.util.list. Your list will come from collection according to the library, will come from collection. And the collection will come from iterable. Collection will come from iterable. Your collection is a child of iterable. Iterable. If I open iterable, java.lang.iterable, lang.iterable, iterable. In this iterable, can you see the method for each? Have you observed that? Iterable is having a method known as for each. When the iterable is holding for each, that for each method will come to collection. From collection, it comes to the set list queue. Because of this reason, for each method, you can work on list objects also, set objects also, queue objects also. You can perform it. All of you understood this statement? For each method, not only terminal operation, for each method, not only terminal method of stream, it will work on your collection objects also. That's the meaning of it. So according to our information now, I am using for each here. Just always I am using Y there. Anyway. One minute. Can you see my screen now? Right. Okay. Now see. Now I am working on this. One exception raised here. Stream has already been operated upon or closed. Already the stream operation over. The stream operated here already. SM. Whenever you want to operate it, again you have to connect the stream. For the second operation, you have to connect the stream. I am connecting the stream again. And I am operating. So stream means only once, no? All of you understood terminal collect? This is terminal for each. This is terminal collect. What is the difference between terminal for each, terminal collect? Anybody can say what you observed? Terminal for each and terminal collect. Terminal for each method is used to display the data onto console. Terminal collect is to accommodate the data into one list. It puts the data into one list, means collects into one list. Collect the data into one list. We are having a method, no, to list method. Collectors dot to list. So whatever you are collecting, whatever you are generating by function, we are collecting into one list. So collect method is used to collect the data into one list, and for each terminal method is used to display the data onto console. Is used to display the data onto console. So this is map. Under map, I am using for each. I am using collect. All of you understood this collect method? Say yes or no to me once, because at least few methods you must learn. If you are sitting for 1 hour also, 1 or 2 methods you must learn. So collect method will support to collect the data to one list. Will collect the data to one list. Right. Some people, 1 or 2 people are confused with this. I'll repeat it. See there. For each method, you will understand it. sm.map. This map method, the stream is coming anyway. ob.stream. The stream is connected. Now, this ob.stream is coming anyway. The stream is connected. Inside the stream now, like this. First, you have to imagine it here. One imagination you must do. Small clarity purpose I am taking. So this is one list. We have a list here. The list name is OB. One list object. The list name is OB. We taken. The list name is OB. 21645. 2, 1, 6, 4, 5. These are the elements. I connected the stream. Stream, you should imagine it like a pipe, because flow no. In this stream, I am using 2 methods. One method is map. I am using map. One method I am using collect. So this is your stream. I selected the stream SM2. All of you understood this diagram now, at least roughly. Imaginary diagram. This is your stream SM2. All of you understood this SM2 holding what now? Map and collect. At least hope you understood this diagram. Now these are 2 pipelined process. We are performing one pipeline process. The data will be taken by map and gives the data to collect. What this collect method is doing now? What this collect method is doing? So collect method is from your stream. Collect method is from your stream. There are many methods available. for each collect. Can you see this collect method? Collect method. Can you see this collect method here? Two methods. In this collect method, we had collector. Collect method is having one parameter known as collector. Collector. This collector. In your syntax, I used collectors. So collectors is one class actually. Collectors dot to list. Collectors dot to list. If I open collectors, Java P, Java dot util dot stream dot collectors. Collectors is a class having one method known as to list. Having one method known as to list. Can you see to list? Now this to list method return type is what now? List. What now? List. Return type is list. Because the return type is coming as a list now. The final information is collectors dot to list. Running internal to collect. Collectors dot to list. Running internal to collectors. And generating one result. It is generating one result. The result also in the form of stream only. Sorry. Result also in the form of list. Here list object will come. It is not terminal. It is a list object is coming. Name of this list object I given here. LST. LST. List object I given. Now map will provide one function. This will provide one function. And this internally create list and load the data to list. How it loads now? 2 into 2. 4 is loaded here. 1 into 1. 1 is loaded. 36 is loaded. 16 is loaded because function is running now. 25 is loaded. Now list object taken the data from the list and kept the data into another list, that only collect. Now you understood collect. Now these two are pipelined methods running and one is intermediate method. One is terminal. Terminal means generating the output in the form of one list. Hope you understood collect, I think. Hope you understood collect. This is from here the data is flown. The objects are flown from list object to another list object. The data is flown. That only stream process. Now, here map is there. From the map, I am using for each. For each means coming outside. Here collect means collecting the data into one list. Collecting the data into one list. It's called collect. And we had one more terminal process, reduce. We had one more terminal process known as reduce. Reduce method will generate the result in a single value. Generate the result in a single value. Generate the result in a single value. That's called reduce. Now, I am connecting one more stream here. I am connecting one more stream. Terminal reduce. I am taking. Terminal reduce. SM3, I will take it. One more stream connected here. Now you have to reduce that value into one single value. It should be reduced into one single value. We are having a method known as reduce. From the stream, we had a method known as reduce. It generates in the form of one single value. I must search it. Here one reduce method is there. See there. SM3 dot map of same value I am taking x into x dot reduce. I am doing some reduce here. I must generate one single value out of it. Whenever I want to take a reduce, I'll take 0. Initial value, I'll take 0. I'll take some answer here. I'll say ANS dot. If not some value, K, I will take it. K plus I will take it. I will add it in some. I'll take it. Now, I'm adding these elements. I'm adding system dot out dot println sum of elements after function. We are applying one function and we are adding them. That is sum. I'm adding. So 82 is coming now. Elements. Reduce method. Reducing means into single value we are making. So hope the answer will be 82, I think. Here. This is 82. If you observe this code now, sir, what is the meaning of this code? Reduce method. Here K value. Already you know the logics actually. Sum is equal to sum plus I you will write in your logics. Yes or no? In your programming practices, whenever you want to add n numbers, sum is equal to sum plus I will write in the loop. For I is equal to 1, I less than or equal to n, I plus plus. Sum is equal to sum plus I you will write. Where that sum is equal to 0, you will take it. Now this k value is nothing but sum only. This k value is nothing but sum. If you take, you can take sum here. Here you take result, you take it. You take result, you can take it. Because I'm adding no. So some value will be 0. Some value assigned with what now? 0. Some value assigned with 0. And I value will take these values. It is mapping the value, no. Whatever the mapped value will come on to this I. And we are adding sum plus I. Sum is equal to 0. 0 plus whatever the result is coming. 0 plus 4. 4 plus 1. 5 plus 36. And dot 16 plus 25. Like this. We are going to add the answer and come. So reduce method will give a reduced value in the form of a single value. It is providing in the form of a single value. So that is known as reduce. So I took a concept map here, but I am doing 3 terminal operations I am doing. For each method, collect method and reduce method. But here intermediate operation, I took map. Intermediate means in between the stream. When the stream is coming, when the object flow is coming, I am performing one map operation. Through that map operation, I am performing one function on the elements. Whenever I performed one function on the element, one result will come. So what I must do with that result? That only terminal operation. The result must be displayed for each. No, the result should be collected into one more object. That is your collect. No, the result should be added. The result should do some operation. You must reduce that value into a single value. Then we are going with reduce. Reduce method will generate the result in the form of single value. Collect method will collect the data in the form of list. For each method will display the data to console. An intermediate operation, I took a map. Through map, I can do some function. I can perform it. There's a theory. Point. If you do on string, it happens concatenation. If you do on string, it will go with concatenations. Same program if you try with string by taking a string objects. Plus symbol will do concatenation. Concatenated string will come. You can try it out. Now, this is giving information about your 3 terminal operations with map. This is a program here. If I am sending a document to you who are in the Google Classrooms, I'll post this diagram and program for you. Program name is demo program 3. Demo program 3. Map I am doing. And I'll paste the diagram. And the output also will be given to you. Who are in the rooms, I'll give the output also for you. Now I want to do filter. I want to do filter operation. Filter means conditional operation. We are performing conditional operation. Filter method. The filter method is used to select elements based on some condition, which means filter method is used to select elements based on condition, which means passing predicate as method argument. Predicate as method argument. We are passing predicate as a method argument. Let us see method signature. Method signature. Let us see method signature once. So I am showing filter. Filter. Public abstract. Public abstract. Return type is string. Java.util.stream. Stream. Filter passing predicate. I want to introduce predicate. Java.util.function.predicate. Function.predicate. Super. This is predicate. I am passing predicate as parameter. Here I introduced function as parameter to map. Here predicate as parameter to. I want to see the structure of predicate. I want to see the structure of predicate. I am opening Java P, Java.util.function.predicate. I am doing. Now, how many abstract methods in the predicate? Name the method. So what is the return type of test now? Boolean. Return type of test is Boolean. So we can use this as a conditional operation. True or false. You can use it. You can use as a conditional operation. You can use it. Having one abstract method. Having one abstract method. Now, using this filter, we are going to filter the data. We are going to filter the data. Predicate also functional interface. So example program. So I'll take one program. I'll take one class here. Always we take product, one class. Public string code name. Always we take product code, product name. Price we take it. Float price. So public into quantity, product quantity to initialize. So I'm taking product string code, string name, float price into quantity. This dot code is equal to code. This dot name is equal to name. This dot price is equal to price. This dot quantity is equal to quantity. So I'm taking user defined class. Last two programs I worked on normal integers, no, generally. So let me try on user defined classes once. String to string method. So return code name price quantity, and this is override method. Anyway, this is one product class. I'm creating one list here. This is product user defined class. I'll take demo program 4. I will take it. Import test dot NIT dot v dot product. Create one array list holding product AL is equal to new array list holding product objects. Import java.util. Add the products ob dot al dot add of new product. Now A102 mouse. Now 123.45 F into 2. This is one product. Like this, add some products. A111, some keyboard 103 and 10. A121, some CDR. Roughly I'm putting one prices 129 and 9. A118. Now floppy disk some 4, quantity 17, zero, zero, some flash drive, some 223 and this is around 18. System.out.println. This is products from list. So here AL dot for each Y. System.out.println Y. Because toString method is there, the answer will be. Now these are the products. So instead of single value, I accommodated 5 products. I accommodated the products. Now on these products, I must do filter. System.out.println. I must do some filter and for each. Means terminal operation for each. Terminal operation for each. For this stream working on product SM1 equal to AL dot stream working. Import java dot util dot stream. Now here SM1 dot filter. I must filter. Here I must give the predicates. I must display the products who are having the quantity less than 10. Who are having the quantity less than 10. So how many products will come out? Less than 10. Sir, only 1 will come. So here I am writing lambda x, where x dot quantity less than 10 dot for each y, and system dot out dot println y. I am printing. Can you see this? Only that's called filtering. Actually, this is actual work we do on user-defined classes. We filtered. So only 1 is coming or not? Only 1. So we return 1 condition and coming out. If you see that I filtered, the condition. X means object. That object dot quantity. If it is less than 10, then display. It is less than 10, that is display. Now I'll say greater than 15. I want to collect it. Greater than 15, I want to collect it. Greater than 15, I want to collect it. If I want to collect greater than 15, how many records will come? Greater than 15 means 17 and 18. Greater than 15. 2 records. So again, I am using filter. I am using filter. Now system dot out dot println. I am using filter with collect. I am using. I am collecting. I am using a stream here. Stream S2. I am collecting the stream. Here I am collecting the data, no? List. Product. LST. Same variable I am taking. SM2 dot filter. X value. Where X value, X dot quantity, if it is greater than 15, dot collect of collectors dot to list. Collectors dot to list. Now display it. LST dot for each Y and system dot out dot println. I am using Y. I'm filtering or not now? I'm collecting into separate now. First program, I introduced how to use for each and collect. Using integers where you can understand easily. But in the real time, the operation is performed on user-defined class objects, nothing but table data. They are working on ORM tools, no? Table data indirectly. Table data will be available in the form of multiple records with fields. All of you understood collect. I am filtering based on one condition. I am bringing the data out. All of you understood this? I am filtering the data and coming out. Now, we had a reduce, no? Anyway, reduce. So sometimes if anybody is maintaining product store, in that product store, total how much quantity is there? Total quantity. Total piece quantity. How many mouses, how many keyboards, the total. I want the quantity, total quantity I want it. I want to add this all quantity. I want to add this all quantity. Right. So reduce. We are using some roughly I'm introducing. When you are applicated, these are all introduction anyway. In applicative level, we apply them in a different forms and we show it. Now I want to use reduce. My intention to use reduce. Let me try it. Filter. Reduce. I'm using. Now I want stream to be collected. SM3. Now SM3 dot filter. Filter. I want to bring the data out. Right. Now I want to filter based on the quantity anyway. So quantity greater than 0 only anyway. Because I want all quantities, no? Yes or no? X dot quantity having greater than 0. Of course, all quantities will come. reduce 0 is the starting value, comma, here sum, comma, I, add it. Sum plus I, you add it. Equal to some int total. Right. Now look here. Now here I dot quantity. Now its mapping failed. It should be loaded. I want to reduce it. I want to add it. So I must add that for every operation, you have to create a stream newly. Because stream means only once. It flows and come out. Every time you have to produce stream. You have to produce stream now. I want to take quantity out. Right. In the quantity process, SM2 dot 1 minute, wait it. Reduce 1 minute. One minute. Now see this. Now I'm mapping this. I'm using a map here. I want to use reduce. I want to add all this quantity and come anyway. I want to take this all quantity and come. I'm mapping with quantity. So I'm using map and reduce. I'm using map and reduce. Filter and reduce is raising an exception to me. I took map and reduce. I'm adding all quantity and come. See there. I'm mapping the quantity. So map means picking the quantity and loading here. If I pick the filter, what happened is the directly object reference is coming. So I'm adding with some plus side, raising an exception to me. User defined class objects. No, I'm mapping. You want to take what means I want to take a quantity, total pieces quantity. Total are 66 available. Total mouses, total keyboards, total CDRs, total N. Total count is 12 plus 10 plus 9. Total 66 available. The concept. So total number of products, total number of products, total number of products, total in quantity. How many are there? Means 66 products are there. Total quantity here 12 plus 10 plus 9 plus 14 plus n. Total number of products in count. I'm counting the quantity and coming out. This is 66 total. Now I am doing operation on user defined class objects. I had one more known as a sorted. Let me do that sorted also. Sorted means ordering, no? Sorted means ordering. Let me finish off that also sorted. Sorted method is used to perform sorting process. Sorted method is used to perform sorting process on stream. Method signature sorted. I'm using normal sorted. Whenever I given a sorted, whenever I given a program, you can work with distinct and so on also. You can use distinct also. Unique values will come out. Somebody asked this question yesterday. Sorted off. You know comparator. If you want to do sorting on wrapper class objects, if you want to do sorting on string objects, you use normal sorted. Whenever you want to do sorting on user defined class objects, you must take the support of second method. So public abstract java.util.stream of sorted off. Here java.util.comparator This is, you must use comparator. When the user defined class object comes, you must take the support of comparator. I am using comparator. Comparator, you know, from java.util, I am using comparator. Whenever you want to use one comparator, I want to order the products based on codes. Or you can based on price, anything. I'll take it on code. Now take one user defined class. sort by code. You take it. Implements from comparator. Writing one method here. Int compare of object OB1, object OB2, product P1 is equal to product OB1, product P2 is equal to product OB2. Int sum z is equal to P1 dot code dot compare to of P2 dot code. If z value equal to 0, return 0. Else if z value greater than 0, return 1. Else RET1, return -1. In a regular core Java, we introduce this. Import java.util. One annotation, suppress it. This is a common logic we use. So our sort by code. Now see there. Sort by code is an implementation of a comparator. I want to pass comparator as parameter so that I can pass sort by code as parameter like this. In our program, I want to sort it. System.out.println sorted. I am using a method sorted with for each. I am sorting by the code. Again, connect the stream. Every time you have to connect the stream because stream means only once. Now here, SM4 dot sorted. Second one, new. I am passing the parameter. New sort by code. Third dot. SM4 dot for each. But here you have to pass sorted method. I must import it now. Import NIT dot v dot sort by code. Then only I can pass new sort by code. Can I see sorted? A00, A101, A111, A121, 180. So we are sorting. Whenever you want to do sorted, this one. These methods will work more perfectly in integers generally, but I'm trying with your user-defined class objects because in real time, user-defined class objects will be there. So new sort by code implements from comparator, taking two objects and deciding which one is lesser based on the code. So based on this, the sorting process happens. This logic generally we explain in core to you, generally. The points. This is unchecked will come. Unchecked. Point. So major methods I tried in a short period. Major methods, map, filter, sorted. And major terminal methods I tried, collect, for each, and reduce. The major terminal methods I tried. So few more methods are there. The way you got it anyway, you can try that way by seeing the different methods. You can try it. Right. So these are a few operations I done it. Whatever I done anyway, whatever I done it up to here, I load in your regular classrooms who are in my Google Classrooms. I'll upload there. So all rooms I'll upload these notes. I can upload there by sorting. And few more method definitions I'll upload there. You can read it and apply. Okay, right. This is small introduction to Stream API. I cannot say completed, but few more methods we must apply it. If any other time is there, I'll do 1 more 2 days on the continuation. Till now, few methods I worked. At least few idea I given. Stream is nothing but one flow of data or flow of objects here. So major operations I revealed to you. Map, filter, and sorted. We call it as intermediate operations on the stream. Collect, for each, and reduce. We call it as terminal operations. So definitely stream will have high performance because internally pipelined process is going to be performed. So all the stream API runs background with Lambda expressions. So thank you very much. I'll upload the notes to you in the regular rooms.